Okay, so I'm looking at your review sheet, and it looks like the exponents get a little bit interesting. So what I'm going to do is, and you have the odd number problems are one way, and then the even number problems are just another example. What I'm going to do is give you step by step on the odd number problems. You work the evens because it's just the same example. Let's see how we do. Alrighty, I'm looking at number 23. Says negative 7 to the second power. Now there's a huge difference here. This is not negative 7 times negative 7. It doesn't equal that. What this means is the negative of 7 times 7. So you're going to get 49 on that. Here's when you would get a positive. Here's what, if it had said parentheses, if it had negative 7 all squared, then you would negative 7 times negative 7 and get a positive 49. That's a huge difference. Don't make that mistake. 25. 6b to the negative 3 power. Okay, so now I've got to do a little bit of preaching here. Let's come over here just on the side. So if you have b to the 4th power over b to the 3rd power, what you have is b times b times b times b over b times b times b. Because this is really an action. It's not really a number, it's an action. That's why I have b multiplied by itself 4 times. Well, anything divided by itself is just a 1. And so I'm left with b. Right? And you might see, oh, well, this is, I could just go 4 minus 3 and get there. Yeah, you could. You could. So let's turn it upside down, though. Let's do b to the 3rd over b to the 4th, which is b times b times b over b times b times b times b. It's a 1, it's a 1, it's a 1, and I have a b on the bottom. Well, these were all 1s, remember? So I have 1 over b. So if we use that same idea, here we had 4 minus 3 and got 1. Well, here we have 3 minus 4, which is negative 1. So 1 over b is the same as b to the negative 1 power. So I say all that to say this. I'm going to switch colors here. It's getting a little crowded. Okay, back. This one is really 6 over b to the positive 3 power. Only positive exponents are simplified, right? Because let's go, if we go down here, if we have b to the negative 3 power, that's really 1 over b, right? But then we had that 6 to deal with there. So there's notes for that. One moment, please. Now we go to 27. (27) is negative 3x to the 4th y squared times 6xy to the 6th. Okay. Now, if you don't remember anything except for what these exponents mean to do, then you're going to be fine on all of these problems, because really what this is, and when I was learning how to do exponents, I did this every time until I saw the pattern. 4x's and 2y's. Now, once you see the pattern, use it. I'm not going to teach it. I want you to figure it out. I think that just teaching something by saying, okay, here's the rule, you rob your learner of the opportunity to discover that. Because once you discover it, it belongs to you. It's not something I gave you. It's something that you discovered. So that's why I'm not teaching the rule. You can figure it out. All right, so negative 3 times 6 is negative 18. And I've got 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6, and 8 y's. Done. 29. Thanks, guys. All righty. Okay, oh, we got all kind of negative exponents here. So let's work inside out, all righty? We know that this is really a fraction. This is really a reciprocal. So I'm going to simplify this first. Here's really what I have. I have 2y squared. That positive exponent is fine. I'm leaving that alone. But these 4x's, they belong down here. And then there's the other x. And I've got all of that to the negative 2 power. Okay, so I'm going to clean that up. That's 2y squared over x to the 5th, all to the negative 2 power. Now we have to deal with this negative exponent. So remember, it's a reciprocal. You can, in effect, flip it over. So this was really going to be x to the 5th over 2y squared, all to the positive 2 power. And now once again, if all you remember is what that little guy there means, you're going to be okay. Now let's get rocking and rolling here. This is going to be x to the 5th over 2y squared multiplied to itself that many times. Now remember up here, maybe you saw that pattern. I've run out of space to write all these x's, so I'm just going to count them up. I've got 5 x's here and 5 x's there. That's going to give me 10 x's. I have 2 times 2 is 4. 2 y's here and 2 more y's here gives me 4 y's. And there's your solution to 29. All right. 31. Now, Connect Math does a fine job of all these exponent problems, but I wanted to just give you some extra notes because I think it can still be difficult. And I remember not really being able to find ones that look quite like this. Okay, 31. All to the 3rd power. Let's do that. That means 5x to the 5th y squared times 5x to the 5th y squared times 5x to the 5th y squared. 5 times 5 times 5 is 125. I have 5 x's here, 5 more there, 5 more there. That gives me 15. 2 y's, 2 y's, and 2 y's, 2, 4, 6 y's. 32. Not 32, 33. Well, hopefully you've seen by now that if you have a negative exponent, that's a red flag. That means that that number of x's are in the wrong place, basically. It's a reciprocal. So this is really x to the 8th over x to the 6th, which is really this. We did this before. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It's a 1, 1, 1, 1, 1, 1. I'm left with 2 x's. X squares your solution, 35. I'm going to need some space for 35. Okay. Alrighty, let's start here. That means this. Times itself. Now, if you stretch it out that way, see, look, once we start to do this, then stretch it out. And I hear you could stretch it out more if you wanted to. Why don't we do that since I have the space? All right. Now, -4 times -4 is negative. It is not. It's positive 16. I have 6 A's here, 6 more there. That gives me 12. And 3 B's here, 3 B's there, gives me 6 B's. Cool, right? I like how when we start it looks very funky and then goes to just very not funky at all. But you have to do those extra steps. They will help you so much. And once you do them enough times, you'll start to see the pattern and it just won't be a deal at all. 35, 37. All right, let's start with this. That really is. And let's don't forget that extra n, which is really, there's n squared, n squared, n squared, the extra n, 5 n's. So I've got 1, 2, 3, 4, 5, 6, 7 n's here. So let's cancel some things out, divide stuff out, let it go to 1. I've got 2 n's left. I'm done. And then 39 is going to get me just in my 15-minute limit for YouTube video. I'm learning so much. I feel so high tech. All right, 39. -21, a to the 0 power, b to the 6th power, c to the 4th power, all over 7, b to the -3 power, c to the -2 power. Okay. I want to talk about that a to the 0 power. So remember from before, something looked sort of like this. Let's say I had a to the 4th power over a to the 3rd power, and we decided that that would be a to the 1st power, right? Just because you had the 4 a's on top, you had 3 a's on the bottom, those give you a 1 and you have 1 left. Well, okay, and so you know that in effect you could just go 4 minus 3 and get that same 1. Well, what if we had a to the 3rd power over a to the 3rd power? Isn't anything divided by itself a 1, right? And if I do that same subtracting idea, 3 minus 3 is 0. So anything to the 0 power is a 1. Anything to the 0 power is a 1. Anything to the 0 power is a 1. Now I'm going to erase this so I can finish this problem, keeping that idea in mind. Anything to the 0 power is a 1. So I really have -21 times 1. And then 6 b's, that's fine. And 4 c's, that's fine. But this 7, he's good to go. We'll leave him here. But look at these 3 b's. They're negative. They're reciprocal. They go up here. Look at these 2 c's, reciprocal. They go up here. Now everything's positive. I can continue to simplify. -21 times 1 divided by 7 is -3. I have 6 b's and 3 more b's, 9 b's, 4 c's and 2 more c's. That's 6 c's, and I am done with about a minute to spare. All right. So y'all take care and be in touch with me. Do math every day. Bye.